Cool, let's wait for the slides. Yeah, thanks everyone for staying until the last talk of the day. Pretty excited to be talking on the Middle East. It's the first time, hopefully not the last time. I just want to take you a few minutes to talk a bit about the tools for data engineering and data analysis. And the reason I mentioned reinventing here is because for many years, Pandas has been mostly a standard in the Python ecosystem. And now there are every time more and more alternatives, and I think for many people it's difficult to navigate, even for people very familiar with that. So I want to give you some information about that so you can make better choices on choosing your tools for these tasks. So just a bit about me. As said, Pandas core developer. Also other things in the community, including IB's core developer. I work professionally in open source, mostly in Pandas, also contribute to via QuantSight. Yeah, I also help teams better do data pipelines mostly. So how I'm going to structure this talk is I'm going to first talk about, in general, this sort of tools. What are the important aspects to look at when you are analyzing, when you're evaluating Pandas or other tools? And the second part, I'm going to talk about the specifics, about Pandas and what are the alternatives and how I see the future on the ecosystem. So first of all, let's start by talking about use cases. I think if you arrive to this wall and you start working on Pandas, it's not pretty obvious that Pandas is solving two different problems. But I think personally, and you can have different point of view, and I think it's a pretty opinionated thing, but I think it helps structure the discussion to say that data engineering is not data analysis. I think if you're working on a notebook and you don't care about your code, you just care about the data you're extracting, that's one task, one kind of task. If you're writing production code that is going to run every night and you need the speed and you need things to be reliable, you don't want things to break, I think that's a pretty different task. To be a bit more formal on that, I would say if your outcome is the insights, is the charts, is the ideas, understanding your data better, you are probably more in the data analysis side. If your final product is the production code and is the transform data, that probably it's going to be also the input for your data analysis later. That's going to be a different kind of task. The users also are pretty different, and I think that's important. If you're designing tools for data engineering, you probably want to have them be good for software engineers. If you're doing tools for data analysis, you probably want to have people not so proficient with Python or with coding, and you want to target different kind of people. Also, your priorities, when you're in a notebook, what you want is an API that makes things easy, makes things fast. And if you're writing production code, what you want is that this code is particularly readable and that this code can be maintained easily. So another thing to look when your problem is which kind of data, or in this case, which size of data that you've got. If you've got megabytes, if you've got something like the Iris data set, probably you're very familiar with, 150 rows, you don't care about the tools, you don't care about performance, whatever it's going to do the job. You can pick anything, like a spreadsheet probably would be a good choice. If you start to be in the gigabyte of magnitude, then you start to require more performant tools. And when you move fire and you start to have terabytes, petabytes of data, then a single computer is not going to be enough. So that's pretty important considerations that you need to have. So in terms of performance in the Python world, I'm going to simplify things a lot, but for the people who are not familiar, I think that will make things easier to understand. Python core developers made a decision of making this possible. Lists with different elements. If you represent this in memory, what it means at the computer level is besides every value, you are going to have to store which type it is. Right? And this is even true if then you store the same type in all your data. If you're using C, you're using Rust, you're using C++, these sort of technologies, what you're doing is you type your whole array, you type it once in your code to say the compiler knows about it, and then your memory only have the data itself. And this is how computers are designed to work, CPU's cache. So Python is never going to be a fast program a fast tool for data. like basically because of this. So what happens? Like this is how you can see software. We have the user in one side, like our data analysis analyst or our data engineers where is writing the software. And the other side you have the hardware, the data that it's basically bits in our hard drive, in our memory. And then you have like the software that's computing everything. And then you have the API that we communicate that we use to communicate the user. In the case of Python, what's been happening and why Python is fast, and I think Python is pretty fast and it's become the standard for a reason, is that we're using Python mostly as an API. Not only as an API, we're programming in Python the things that are not important for performance, the operations that are not related to our data of all these arrays. But for everything else, we're using different things. We're using C, we're using NumPy that is implemented as C extensions, we're using Python. There are different technologies that we're using, but we're never using just Python the way that you would write a Python program. So just to give you an idea, if we're not using Python for the data operations and Python just for an API, you can imagine that you can have this code in pandas, just like a very simple pipeline. I think you can read it well enough, just reading a file and filtering and summing over a column. But you could express also the same thing with a configuration file. At the end of the day, it's going to be C who is going to process all this. Python is not being used for doing the computations. So with those things in mind, like the use cases, the different use cases that we can have, if whether performance is important and how much, and which API we want to use, and we can see like that there are like an infinite amount of tools that you can use. In the left side, you have like all the tools that are not Python or Python specific. You can use spreadsheets, as I say, like for data analysis, you can use spreadsheets. I think is a pretty reasonable choice if your data is on the order of 100 rows. You have databases. There is a lot of things on data analysis that you can do on databases. You have business intelligence systems. You have other programming languages kind of equivalent to Python, like R or Julia. You have new tools like DuckDB. And then on the Python side, you have many things that are quite inspired by pandas. It's like 10 of them. I'm not going to go into the details. I want you to have the names. And also, I'm going to have this, just a disclaimer, it's down there. It's pretty opinionated. Like I'm talking about the maturity. I'm talking how fast are things. I just made some choices. You can disagree. It's perfectly fine. And you can research like for your use case whether this makes sense or not. But you can have an idea here that we've got pandas. Pandas is pretty mature. It has a backend based on NumPy. And it's fast. I mean, it's pretty fast, but it's not as fast as it could be. That's why I didn't check on the fast column. You can see Dask. I didn't check fast, even if Dask is probably one of the fastest, because you are going to parallelize over a cluster of data, but because it's based on pandas, it could be still faster. I think it's pretty mature. Some others are mature. There are some new challenges, like Polars, for example, looks pretty promising. I don't think it's very mature yet, even if some people started to work, and I think they're getting pretty good results. A pretty interesting one here is IBIS. There are question marks, not because I don't know. There are question marks because the backend, like how you are running your code, the data operations I was mentioning, those are work as plugins. You can be working with IBIS with a database. You can work with IBIS in a Spark cluster. You can work with IBIS with Pandas data frames. So it's just like the API. We saw the chart before, like what's an API and what's the data operations. IBIS is designed this way, so it's a pretty interesting option here. So we see so many different options. Why Pandas-centric? Why all these tools are so inspired by Pandas? Well, Pandas is pretty mature. It's probably one of the oldest there, and particularly users spend a lot of time getting used to the Pandas API. The Pandas API is probably not the ideal API I would like to have. It would personally change so many things. We're not changing things because we want to be backward compatible. We don't want that at every version of Pandas you need to learn everything again. So we're keeping those things, and that's like basically constraining us to improve. But Pandas also has a pretty huge code base. Like it's a mature project with many core developers. Development is slow. You cannot distribute pandas. You can use other tools to distribute pandas, like Dask, but pandas itself is not a distributed technology. So yeah, pandas has pretty advantages. I would say like pandas is a safe choice for many cases, but it has many challenges that open the doors for all these alternatives to fix problems that pandas has. So how I see the future personally, this is a very opinionated thing. Of course, nobody knows the future. If I knew the future, I would be probably trading in the stock market, not talking about pandas here. But how I see things is a much more modular approach. I think what we're solving here is a very, very complex topic, a very complex problem in many different ways. It's like the API of pandas is huge. Only DataFrame has more than 200 methods. As we see, like it's a single API that it's working for both data analysts and data engineers trying to solve all these problems. So how I see things is like there would be some discussions at some point just about APIs. I say like we have the pandas API, it's here to stay. So many of these projects are copying the pandas API. We have IBs that it's just trying to design the API and then letting the backends do the work. Then we have SQL. I think SQL is gonna, we were just discussing a minute ago, is gonna stay there, and we want to integrate it with the tools. Users are familiar, probably more users are familiar with the SQL API than with the pandas API. And I think what is missing is engineering APIs. I think pandas is pretty good for data analysis. I think pandas makes things extremely magic and easy. You just say pandas read CSV, and pandas is making a lot of assumptions for you. I think like APIs that are designed for data engineers that basically don't make assumptions and that make code readable and code maintainable are still missing. I think Polars is probably doing the first step on that, on moving a bit away from the pandas API, but I hope more will come. On backend, there is a significant amount of work. Like I think some of the important projects, I mean, this is not like trying to say those are the only tools, the only possible backends. Like IBIS has so many of them. We can use databases. We can use like Spark. We can use like any other cluster. But Arrow kernels are a pretty interesting thing to watch at because they are trying to build something that can be reused at any project inside databases, in tools like pandas. Then we have data function that is built on top of that. DuckDB is trying to also bring like a similar approach to that. Then we have the distributed part that I think this is pretty modular. You can distribute on RAID, you can distribute on Spark, you can distribute on Dask. Like there are different tools that can use this. And then the data representation has a different amount of options and work. Because when we want to build APIs and build things in a modular way with different APIs, what we also need is like standards on the data representation. So Apache Arrow, for example, is representing like a standard for in-memory data. We have Substrate that represents like the query plans. I was showing the API like before on two possible pipelines. Substrate tries to represent internally those different pipelines, so you can have the API translate to a common query and then send it to any backend. Then you have like the different data formats. There is a lot of standardization on that too. And of course, like we can use databases also for many things. So just my conclusion. First, if you are evaluating like tools for data analysis or data engineering, try to understand your problem first. I told you a few things you want to understand. Try to understand well which problem you are trying to solve. It's not the same like data analysis that data engineering. Just try to make sure that you understand your performance, that you are using tools for the right size of your data. Otherwise, it's going to be pretty painful if you have petabytes of data and basically what you are trying to use is Panda. And also like consider the APIs. Like if your users, and in this case your users is probably your employees, are used to the Pandas API, probably move in that direction. If they are going to be like new to that, maybe you can train in different technologies. There are many different options available now. All of them have advantages and disadvantages. All have like, there are always trade-offs. And as I say, like there is the problem is too complex. Probably what we'll see is a more modular approach, and instead of just choosing like one tool, saying like, okay, this is Pandas, Pandas is going to solve all my problems, you're going to say like, okay, I want this API, I want this backend, I want this data representation, I want to distribute it with this kind of cluster. I think we are going to be moving more and more in that direction. So this is everything from my side. This is, you can see you can find the the slides in my channel in Telegram. Also, if you want to connect on LinkedIn, is the same username. And I hope we have time for questions. Shukran.
Yeah, we have time for questions. Are there any questions for Marc?
Just quick question. Do you know if there's like any I don't know, any project or any intention to add more type annotations to pandas, for example, to declare the types of the data frames, maybe if they are known beforehand or something like that, to integrate a little bit more type annotations with the pandas data frames?
On types, you said?
Yeah,
Sorry.
with the type annotations, type hints. Like, for example, to say like, oh, this column is going to be an integer, because pandas already has a lot of great inference on the information, but that is known at runtime, and I don't know if there's a way, maybe a plan or something to have that for
good question. There is work on this actually since Pandas 1.4 that we released, I think, 3 weeks ago. We started, there were 2 projects for adding type annotations to pandas, like Python type annotation. It's named Pandas Stubs. There were 2 projects like coming from different sources that we basically unite in one. So you have that. It's a pretty challenging topic, I would say, because Pandas API is designed to make things magic in a way. And like a single operation can return so many different things, like depending on how many columns your data frame has, can return like a series or a data frame or like so many different things. But yeah, Pandas Stubs is in the GitHub Pandas organization since very recently. That's probably what you want to look at.
Amazing, thank you.
Great, any more questions? Oh, we have another question.
What do you think is, or how would you compare IBIS to Polars? Do you think either one is better, or like which one would you prefer?
Yeah, that's a very good question. I think in a way they are not even so much competitors, because I think Polars, the main advantage of Polars is like the backend, what it's implemented. Polars, even you can use Polars without pandas. You can use Polars directly with the Rust API, so you could literally implement like an API in SQL that runs your code in Polars. While IBIS, it implements a lot of backends, but the main thing that IBIS implements is the API. So what IBIS tries to implement is an API that is similar to pandas, but it's different. It's not like the same. It doesn't try to be the same. It has differences. So yeah, I see a quite likely thing to have. I don't think it's like there is work, or at least that I know, on IBIS working directly on Polars, but I know that there was interest on IBIS working in data fusion. That it's like I think it's like the underlying part of Polars, like like a bit like what's under the hood. So yeah, I don't think they compete that much, and I think they are 2 very interesting projects to watch.
Okay, thank you very much, Marc. Let's thank you once again.